So far what we did is we had a point, so that was given, and from that point we found the gradient. So we have a curve, suppose a parabola, so there are many points on it, and for every point we can find the gradient. Now let's see, what about the reverse situation? Suppose we know the gradient and we have to find the point. That means we know that there is the gradient for a particular point. We have to figure out what that point is. So that is just the reverse. It should not be any different. Let's see. So the question here is, calculate the points on the curve with equation this at which the gradient is equals to 16. So let's do this. Let's find the gradient of the curve. So derivative of y is dy by dx, which is known as the gradient. The derivative of 7x squared is 7 to the 14x minus 3x squared. Now given dy by dx, or the gradient, is equals to 16. So now we know that the gradient is equal to 16. Therefore the expression for the gradient, which is 14x minus 3x squared, equals to 16. So we can write minus 3x squared plus 14x minus 16 equals to 0. So what we can do is we can multiply by negative sign. We can write 3x squared minus 14x plus 16 equals to 0. So now we have to do, this is a quadratic equation, and we have to do middle term break to solve this quadratic equation. So let's try to do this. This is going to be a bit difficult because the numbers are large. So 3 into 16 is 48, and we need 14. So 48, how can we break 48? Well, we can break it as 24 into 2, that's 48. So if we add 24 with 2, we get 26. If we subtract, we get 22. It doesn't work. Other simpler thing is, we know the tables of 6. 6 8s are 48. Well, if we add, we get 14. So we can use this. So we can write 3x squared. Now we need minus 48. So for that, we will need minus 8x minus 6x. So that would ensure minus 48. So let's take x common here. We cannot take anything else common, so it will be 3x minus 8. Now this is 16. So now let's take 2 common here. This will be 3x minus 8 equals to 0. So if we take 3x minus 8 common, we will get x minus 2 equals to 0. Therefore x equals to 8 by 3, or x equals to 2. So we got two values of x. Now a point is made up of both x coordinate and y coordinate. It's an ordered pair, so we have to find the values of y also from here. So we have to write, when x equals to 8 by 3, what is the value of y? So y equals to, this is the equation, so y equals to 7 8 by 3 whole square minus 8 by 3 whole cubed. So this is going to give us a value, and when x equals to 2, we're going to get y equals to 7 2 squared minus 2 cubed. So this is going to give us another value. So the answer is going to be x coordinate first, y coordinate, and then we write the other x coordinate and the other y coordinate. So we have used the gradient, and from the gradient we have to find the values of x, which is the points. Let's do one example. Find the x coordinates of the 2 points on the curve with equation x cubed with the gradient 1. It can happen if this is the curve, there might be 2 points where the gradients are same. So we have to find if that gradient, suppose that is 1. So dy by dx here is 1, and dy by dx also is 1 here. So we have to find the point. We don't know what the point is. So we can do this. Let's start with the gradient. So dy by dx, so this is going to be 3x squared minus 11. So when dy by dx is 1, we know that the gradient is 1. Therefore, 3x squared minus 11 equals to 1. 3x squared equals to 11 plus 1 is 12. Therefore, x squared equals to 4. And we know x equals to plus minus square root of 4. That becomes plus minus 2. So we have two values of x. So one is x equals to 2 and one is x equals to minus 2. We have to find the corresponding values of y. So when x equals to 2, y equals to, remember this is dy by dx. This is y. So y equals to 2 cubed minus 11 into 2 plus 1. That's going to give us the y value. When x equals to minus 2, then y equals to minus 2 cubed minus 11 minus 2 plus 1. And that is going to give us another value of y. They didn't ask for the point as the answer. So we can either state the answer as x equals to 2, y equals to something, x equals to minus 2, y equals to also something. This is another sum similar to every other sum. So f prime x, usually we can get y equals to fx, but it's fine. So we have to find f prime x. So if fx equals to x plus 9x to the power minus 1, we take the x upstairs. So the derivative of fx is f prime x, which is derivative of x is 1 and this is 9. Derivative of x to the power minus 1 is minus x to the power minus 2, which gets 1 minus 9 by x squared. Now in question number B, we have to solve f prime x equals to 0. So f prime x equals to 0. Be careful, this is not inverse. This is f prime x. So therefore, f prime x stands for 1 minus 9 by x squared equals to 0. We can write 1 equals to 9 by x squared. We can cross multiply and write x squared equals to 9. Therefore, x equals to plus minus square root of 9, which is plus minus 3. In this particular question, the algebra is a bit difficult. Let's try this. First of all, let's start with simplifying the bracket. X to the power 3 by 2 minus 1. X to the power minus half plus 1. So when we simplify this, we have to use the indices simplification rule since we have powers here. So x to the power 3 by 2 into x to the power minus half. Then we have plus x to the power 3 by 2 into 1, which is going to give us x to the power 3 by 2. Then minus 1 into x to the power minus half. Then we have minus 1 into 1 is minus 1. Now we can write x to the power 3 by 2 minus 1. This rule is the indices rule. X to the power a into x to the power b is x to the power a plus b. So that means 3 by 2 minus half. This would be x to the power 3 by 2. This would be x to the power minus half. And this is minus 1. So 3 by 2 minus half is 3 by 2 is 1.5. Minus half is 0.5. 1.5 minus 0.5 is 1. So it's going to be only x. So x plus x to the power 3 by 2 minus x to the power minus half minus 1. Now in question number B, we have a curve which has this equation. So y equals to this. So let me write the simplified version. So y equals to x plus x to the power 3 by 2 minus x to the power minus half minus 1. Now let's differentiate this. So dy by dx. The derivative of y is dy by dx equals to derivative of x is 1 plus this would be 3 by 2 x to the power 3 by 2 minus 1 minus this would be minus half x to the power minus half minus 1 and constant is going to become 0. So 1 plus 3 by 2 x to the power 3 by 2 minus 1 is half. Minus into minus is plus. So minus half minus 1 is minus 3 by 2. Let's make the power positive. So 1 plus 3 by 2 x to the power half plus 1 by 2 x to the power 3 by 2. Now question number C. At x equals to 4, dy by dx, we have to find the gradient of the curve at the point x equals to 4. So all we have to do is plug in this value in this derivative. So dy by dx is 1 plus 3 by 2. So 4 to the power half plus 1 by 2. 4 to the power 3 by 2. Now the indices skill come in handy. So 1 plus 3 by 2, we know 4 is 2 squared, and when we have a power over a power, the power is multiplied. Plus 1 by 2, 4 to the power 3 by 2 is 4 squared into 3 by 2. We can write 1 plus 3 by 2 into 2. This 2 and this 2 cancels. Plus 1 by 2. Now here we have 2 to the power 2 into 3 by 2. This 2 and this 2 cancels. 2 cube is 8. So we can write 1 plus 3. This 2 and this 2 cancels. Plus 1 by 16. So this is 4 plus 1 by 16. So this is 65 by 16.